right, Peter, how are you doing today?
Hey, great to see you again, David.
Yeah, it's been great. I know we had to move this recording a few times, but I'm glad we made it to this particular conversation. For everyone listening in, today I'm speaking with Peter Kraft. He's a co-founder of this amazing, exciting company called DBOS. In preparation for this, I've been trying around the product, and obviously we are also working with DBOS as partners. So there's some exciting stuff that we wanted to talk to you about. But before we get into all of that, Peter, tell us a little bit about yourself and where you're based out of and what made you do what you do today.
This all got started with back when me and my co-founder Chen were in grad school together at Stanford, and we were working on the idea that turned into DBOS as a research project for basically the last half of our time in grad school. And the idea that we developed in grad school eventually turned into the company was what happens if you take all of the state of your application and store it in the database, right? Can you make your application as durable and reliable as the data you already store in a database is? So we took that idea, we played with it in the research side, and then we realized it was something that was a really powerful idea. And if you did it this way, you could build really, really reliable software very easily. So the two of us took this idea and built a company from it. And we've been working on that for the past couple of years.
And that's awesome. You're too humble in your introduction. I mean, you were at Stanford, working on this for a bit. And you were also working alongside, Michael Stonebraker, the legendary
Yes.
Michael Stonebraker, who's behind Ingress, behind Postgres, and then obviously Matei Zaharia, who from the Apache Spark fame that turned into Databricks. So you're working around and being around some really good heavy hitters. So
Yeah,
that's also
absolutely.
exciting.
Yeah, Matei was my advisor in grad school, and then Mike at MIT was like the lead on the overall research project. So he was the one who originally, he'd been looking at variants of this idea for maybe 20, 30 years, and then we finally came together, him and Matei, and decided to actually go build with it, and that's what turned into DBoss.
Yeah, I mean, it's super exciting. So, for everyone listening in, I mean, obviously, there is so much we wanted to talk about, and especially in the context of, why you're building, I would say the right way to put it, reliable workflows backed by database infrastructure. Like that's like a sweet spot, and the world of AI agents is it's going to become so much more relevant. So, we want to cover all of that. But for our listeners who probably are people who are like probably regular developers, architects who are from the try catch exceptions era of coding, or which is what we typically do, to help people understand what makes DBoS different. Like, what is DBoS?
Yeah. So at the core of it, DBoss is a really lightweight database-backed library for durable workflows. So that's a lot of words. I want to break it down. What DBoss does is that as you run a program, and that program can be an AI agent or it can just be a normal program, DBoss regularly checkpoints your program's progress in your database. That's kind of like save points in a video game, where in a game you play it, and every so often you save your progress, and if you die, you can reload from your last save. And DBoS every so often it checkpoints your program's progress to the database, so that if your program fails in some way, if it crashes, if something goes wrong, if your internet cuts out, you can go back and reload from the last checkpoint saved in your database and resume your program as if the error didn't happen. That's the core of it.
Well put together. I mean, this concept that you're talking is well understood in the database world, right? Like we know transactions, we want to make sure transactions are durable, acid, consistent. But what you're doing with DBoS is bringing that to the application level, right? And making sure that if it's AI agents or if it's like actual application code, you're giving users the ability to have durability. And one of the best ways in which I started thinking about Diva. So here's a true story. I've been working with a partner recently. They have a 30-year-old application. Okay. Insanely complex application, really good application, great team, smart people. But the level at which they have written retries and scenarios where things can go wrong is excessively put into the application code. So I was just joking with one of my teammates, man, they need debars because if you can write just simple code and that code can have checkpoints, you don't have to write that application logic to like save the progress, remember did the processing fail, Can we try that transaction again? All these things you can have in the application code itself. So that's super exciting. So I'm really excited about a future where people can start coding, with DBOS from the perspective of thinking about just code and not to worry about workflows.
Yeah, exactly. Like it lets you write normal code that you annotate workflows and steps, which is and then it just works. And if there's a failure, it just recovers. You don't have to consider every single possible point at which things could go wrong and write special casing for all of it.
Right. It's pretty cool. So tell me a little bit about when you were at Stanford. Was this part of your actual project, and this is what turned into Divas?
At Stanford, we were looking at a more researchy level of what happens if you store application state in a database in general. And we looked at it from several angles. We looked at application state. We also looked at operating system state. That's where the original DBOS name came from. And that led to some research papers. But the core idea that I think excited us the most was that you could build this really lightweight interface that stores specifically application state in a database. An interface look like more durable workflows. And then that's the idea that kind of that wasn't really what was written in our papers. But that's the big idea we took away from our papers. When the two of us graduated and went off to found the company, that was the idea that we started building. This really lightweight, totally database backed workflow system that you could put into any library. You could just build this library and put into any application. It would just work.
I've worked on other workflow orchestration systems, and I think if you can highlight how DBOS is different from workflow execution systems, because there are existing workflow executions orchestration systems. They also kind of do something similar, or I would say they're trying to solve a similar problem. But what comes with that is the complexity of learning that workflow orchestration system, right? So you're not thinking about code, you're thinking about how can I fit my code to work with this orchestration system. What I started to appreciate more, and this I'm talking from just the last 2 months of my team working with your team and me trying to do some personal experiments, is I actually think about the code and not about the orchestration, because I know that DBOS can kind of handle that. So there is a big difference in the way the workflow orchestration system is trying to provide the same kind of feature or capability, and the way how you guys are trying to solve it. Can you elaborate on that a little bit?
Yeah, exactly. What we're trying to do is make it as simple and lightweight as possible. I think the classical model was an external orchestrator. That's the way workflow
Mm,
systems used to work, where you have, you know, you write your workflow maybe as code, but more likely as an explicit DAG, and then you load it into a big orchestrator like Airflow or AWS Step Functions, this explicit DAG, and this thing goes out, and this orchestrator calls out to whatever workers are running in your cluster and tells them to execute steps. And that's tricky because you have to write everything in terms of like steps in an explicit DAG running on a cluster that this orchestrator manages. That works. That's hard. And that requires you to rewrite your program. What we're trying to do in DBOS is kind of like strip workflows down to the bare essentials. So it doesn't require all this infrastructure. All it needs is a library that runs in your process and checkpoints your workflow's progress.
right.
So because all you really need for you don't a workflow system doesn't need an orchestrator. It doesn't actually need to manage your program's execution. It just needs the checkpoint, the progress of your program to a database. And DBOS does exactly that. And that's a really powerful idea that gives you all the benefits of workflows. It gives you durability. It gives you queues. It gives you distribution. It gives you observability. It gives you workflow management, the ability to query everything your program has been doing. But it does that all without the footprint of a giant external or orchestrator or a big new cluster you have to manage.
Yeah. No, I agree. I mean, and then that's the piece that I would love if you are a listener who is trying to think about what should I do. Go check out Dbus. I mean, I'm plugging kind of shilling Dbus here, but I truly believe it's something different and exciting. And I like the simplicity of the code, right? Because I had an example where I had like this long code, and I completely replaced that in like 8 lines, and I was like, oh, look at this word. I
Mhm.
like the way this looks, and it's code. I'm not thinking about an external system. It's all part of the process. So it's cool. Um, so let's take a quick turn towards, the world that are in today. I'm pretty sure every person you walk out, including my daughter yesterday, said, Daddy, are you using AI to me? Right. So pretty much it's like my daughter's 7 years old. But the reality is pretty much everyone is aware of AI and the impact of AI and what it's doing. And you have spent considerable amount of years, researching, working on distributed system, databases, cloud infrastructure, orchestration systems, workflows. Why do you believe the next reliability crisis will be driven by AI agents?
Well, have you used an AI agent?
Everybody uses it, right?
Then you know exactly why the next reliability crisis will be driven by agents. Because if you use one
Yeah,
for 10 minutes, it'll do something unreliable.
for sure, for sure. Yeah, but in the context of what you're doing with DBOS, like how do you think DBOS fits in the story and can help our users out?
Yeah. So DBOS helps add reliability agents on two levels. So one of them is the more basic infrastructural level, where if your agents are really long running, and increasingly agents are, DBOS lets that agent, you know, DBOS lets the agent run reliably and resume from failures. And if your agent is running for hours or days, failures are inevitable. Servers have to be upgraded, processes crash, and internet cuts out. The Anthropic APIs fail every 10 minutes. Like
Right.
this sort of thing. So if you're running long running agents, you need this infrastructural resilience, and DBoS provides that. Then the other level at which DBoS provides reliability agents is reproducibility. This is, I think, the more interesting and higher level. And this is that DBoS is checkpointing your agent's progress. And you can use that not only to recover an agent from a failure, but also to reproduce agent behavior, to restart your agent from any point in its execution history. And this means that if your agent does something that's not really a failure, but is unexpected, then on a particular step, then if you're building it with DBoS, you can debug it. You can reproduce that behavior. You can take that agent and replay it from exactly the state where it was when it did the unexpected behavior, and keep iterating on that. Maybe changing the underlying prompt until you've reproduced the behavior, until you've root caused it, and until you've fixed it. This is really powerful because it lets you go and find all the weird things your agents doesn't do in production, and then easily reproduce them exactly in dev, reproduce the conditions that led to them in dev, and over time fix these unexpected behaviors.
Right. And for managing all of this state right now, it seems like DBoS is also heavily coupled with the database, right? Do you think that is by design, and you found that that is how it is should be?
This is what databases are built for. This sort of complex state management, often where you want to do like elaborate queries over the state. You're trying to find like how many times does this particular failure occur. That's a complex query. That's exactly what SQL and databases were built for. So this is storing the state and querying the state. That's what databases are great at that. And that's why they're exactly the right abstraction to use here.
Makes sense, yeah. And I know right now, DBoS supports Postgres, and then we have support with CockroachDB as well. Two different databases, kind of similar ideas, but the completely different scale and resilience offered between these two databases. Obviously, you are working on durability. You also have to provide resilience. So, what are the decisions and the choices you have to make sure that this can work at agent scale?
I think what it comes down to is that the main thing is just you have to checkpoint every single step the agent takes. And what's nice about agents is that their steps tend to be fairly large and complex. Like an agent step is something like call out into an LLM or execute a tool call. Those are big, bulky, expensive steps. By contrast, a single write to a CockroachDB cluster or to a Postgres database is not that big. So that means that the overhead you're adding is actually minuscule because your agents are so expensive and so big that adding one a database write is nothing compared to an LLM call.
Right.
So it just works.
Yeah.
Your cockroach, this is compared to what else you're probably already doing with your CockroachDB cluster. This is nothing.
Right. Yeah, I agree. And I think what people are not anticipating is, and this is it's a thing that when you just mentioned, like, have you used agents? I'm like, yeah, you used agents. I have like 10 agents running and working for me. Like, so somebody like me who's like running 10 different workflows, like even agents are sort of like basically playing out workflows from me, right? Like it would be a little bit high level use cases. What I'm coming to notice is that the world or the industry is still not understood at the scale at which a normal human being will start using agents, right? So if one human starts to run 10, 15 different agents, they might be scheduled working at different times. The impact on the infrastructure and the the perspective that you have to start considering durability, reliability is going to become very critical. Like you don't want to come back after 2 hours and know that your agent failed, and so we at Cockroach Labs are also thinking about how can we make sure that the world that is going to look like agents running all the time. How can we make it reliable and durable from our perspective as well? So that's the focus that I see from our side. What do you see that people are not recognizing in this early stage as they start applying these agentic systems, and where should they start considering it along with DBOS?
First, agents are getting longer running. And that means that just the raw infrastructural concerns, like what happens if my agent runs for 2 hours and during that 2 hours I have to do a server upgrade? That's not a hypothetical. That is going to happen. If your agent runs for 2 hours, you're going to do a server upgrade at some point when you have thousands of agents running. And that means your agents have to be resilient to server upgrades. That means that they're resilient to that means you and then basically to make an agent resilient to a server upgrade, you have to do exactly what DBOS does. You have to take the agent, checkpoint its state, store it into something persistent like a database, and then after you've refreshed your servers, go resume the agent on a new server. So just if your agents are long running, it's the basic infrastructural stuff requires a workflow engine like DBOS.
Makes sense. Yeah. Shifting gears a little bit, if somebody wants to get started with DBOS, is it great to use DBOS for a new application, or or do you think it's easy to start thinking about it in the context of, say, a traditional app, and they're trying to modernize that and make sure they're adding these new paradigms to their system?
Both, absolutely both. Like one thing we've designed DBOS to do, of course, you can use it to build something from scratch. It's always easy to build something from scratch. What we've really, really, really focused on is making it easy to add to an existing system. And that's why being lightweight and simple is so key to us. That's why we built it as a library that you can install in any application. Uh, because in particular, most importantly, DBOS is incrementally adoptable. You can take this library, install it into a big application, and then maybe only take one key workflow that really needs to succeed and annotate that with DBOS. Register this thing as a workflow and annotate its steps. And then
Right.
you can leave the entire rest of your application alone, but just this one workflow is now running on DBOS and is reliable and will be automatically recovered if your program fails. Then if that works well, maybe you could take a second workflow and a third workflow. And then over a few months, maybe you've modernized your entire application. But the key is that you can add DBOS non-intrusively and you can add it incrementally. So you can slowly over time add resilience to a large application that already exists. And you can do it using infrastructure that already exists. Like if you're on CockroachDB, you just connect to existing Cockroach. You don't need to spin up anything new.
Right. It completely makes sense, because all you're doing is bringing DBOS into the application layer. The database layer should work as it is. Based on that, we've been talking about AI agents, agent scale, all these different things. Um, do you think there is a need for human in the loop with the way things are still going with agents?
Yes, absolutely. I mean, that is over time, maybe we'll see less of it, but well, actually, that could go in either direction. We might see less of it because agents are getting more or are getting smarter. We also might see more of it because agents are being asked to do more important things, and those more important things need a human in the loop. And when you have a human in the loop, that makes agents that's something that makes agents longer running. Because now agents are going to have to spend a lot, have to spend human time, and the human isn't always at their computers. That human time might be hours or days to wait for people to wait to get permissions or approvals. And when you have these long running agents, when you have maybe tens of thousands of agents, most of which are currently blocked waiting for a human approval, then now you really need infrastructure to support agents that can run for a long time, can be suspended, can wait for hours or days for human approval, and then the stuff like workflows and checkpoints just becomes critical.
Right. And this is important because when you build systems like this, one of the common occurrences, like, so what I do sometimes is I'll have bunch of agents running, and this agent is waiting for me to approve a Slack message. And then I get on a call, I'm not available for an hour. He's still stuck there. Sometimes I've noticed that the connection will fail. Like, it's basically waited for an hour, and then I have to ask the agent to do the same thing again. And this is a pretty real use case. And I'm sure what you just explained is what people are going to start observing, is that when they run long running agents, they have to make sure that they do some sort of a state management that
Exactly.
they need to build into it.
Like when we
Yeah.
talk to our customers, the ones who are running agents that run for hours or days, the biggest reason the agents run for a long time is because the agents have to wait for human approvals. And as soon as you introduce a human to the loop, a human, like you said, the humans in meetings, the human has to use the bathroom, the human's not always at their computer. as soon as you're assuming the loop, you have to budget like at least a couple hours. And if it's not, or maybe a couple days to get that human response, your agent has to be resilient to that.
Right. No, absolutely. It's a great point. What are the customers that you're seeing start to adopt DBoS, and it's really understand the power of what you guys are offering?
I'd say probably about half of our users are building agents. We're seeing DBoS used for a lot of different parts of of those agents. Some of the users are like we mentioned earlier, using DBoS to make really long running agents resilient. So building agents that can wait for human approvals, that can wait for hours or days, and keep going. Some users are using DBoS to build the data pipelines that power agents, like some using DBoS for document processing, where you have these data pipelines that are processing millions of documents, and those are big distributed jobs that have to run across dozens of machines and run for hours, and are going to inevitably deal with a lot of failures. And you use DBoS to make sure that you can process these 100,000 or million documents durably and make sure they all actually process no matter what failures happen. Some people are using DBoS for agents that have really complex distributed tool calls. Like one of our biggest customers is doing deep research agents, and those agents have really expensive web scrapers as tool calls that are resource intensive. So an individual
Right.
agent has to run distributed over several servers, and then DBoS coordinates that and makes sure that even when the agent fans out to 100 of these parallel web searches that each consume a lot of memory, that those all complete. And maybe if a process ooms, that process eventually gets recovered and the web search is all complete and the agent can go back to what it was doing.
Right. Makes sense. Yeah. Is there an effect of using DBoS with your existing code in terms of the application performance, or do you think it's going to get improved because the application doesn't have to do a ton of things now?
If your application was already doing something for reliability, if it was already resilient to failures, then DBoS is heavily optimized. It's probably faster than what you were doing already. And if you're adding DBoS and overall, especially for a agentic application where, an individual step is something like an LLM call is going to take a few seconds or a tool call that might also take a few seconds. DBoS is all DBoS needs to make its checkpoint is a single database write, which is a couple milliseconds. And that's really nothing for most of these applications. So performance overall is totally fine. Like most people are focused on the performance of their agent and not the performance of anything else because it's just 1,000 times slower than anything else in their system.
Yeah, and I think agentic systems have to kind of there's a trade-off also, right? If you've noticed it, that an agent has when it has to do something, it has to probably pull in a certain number of tokens, input outputs, and it's trying to process them out. It's going through results, and then at some point, it's also has to save these actions somewhere, and then also has to manage the state. So there's a ton of things happening. So if an agent stops after it's pulled in, say, 500,000 tokens,
Yeah,
then you
exactly.
ask it to go back and do the same thing again.
Like, if it can
It is
save
now
you
not
if you can take one long running agent
yeah,
execution and resume it from the middle instead of resuming it from the beginning, that has saved you more time than every database checkpoint you've ever done.
exactly. Yeah, and I think what you said is one of the best analogies, and I'm going back to it. You introduce DBoS as how you're playing a game, and when you play a game, you want to checkpoint the game or save the game at different intervals. Because how much is it that we who gamed hated it that you made certain progress,
Yeah.
and then you're like, shit, I haven't saved the game. I need to replay the whole thing again. And I
Yeah,
think that's like the easiest way to explain what DBoS can help with respect to agents. Because
yeah.
from my vantage point, yeah, go ahead.
Yeah, you're spending, 3 seconds on a save screen to make up for an hour of actual gameplay that you don't wanna redo.
Exactly. Exactly. Yeah. And I think one of the implications of this agentic stuff, and I think we could dig into this as well, is the cost effect, right? The token cost is, it's a considerable amount of money that is going to get used. And if you run agents that are failing to maintain state and are not saving where they need to start off from, then you basically replay those tokens again, and that can be considerable cost at scale, which is something that I don't think people are talking a lot about. How do you feel about that?
Yeah, absolutely. Like, this is especially for actually, the document processing use case won't we see that a lot because in a document processing use case, you're that's where the cost can really balloon, like, because a single job can actually then be hundreds of thousands of documents, tens of millions of tokens. That's something where the cost of a single job is so high that just durability on that one job is and not having to restart it from scratch is a meaningful time and money saver.
Right. Makes sense. Yeah. And, I think one of the things I've discovered while I was using DBoss is that it's fun. It's pretty easy to start off with. Like, you already are providing like Python code. What else do you have for other users? Like, can you elaborate on what programming languages that you support right now? I was using Python, but can you elaborate on that? Because Python was really easy to get started with.
Languages right now are Python, TypeScript/JavaScript, Go, and Java. So those languages are all at parity. So Go and Java are a bit newer, released late last year. Python and TypeScript are original languages. Those languages are all at parity. So features built in one all get ported to the others, and they all share a common system database implementation, a common database schema. They're all interoperable, so you can actually, enqueue a workflow from TypeScript into Python or Java, which is actually something people want to do because you have a TypeScript web server backend that you don't want executing complex jobs. So you have it in QA workflow in your Python or Java worker that actually goes and executes those jobs. So they're all at feature parity, they're all interoperable, and you can get started in any of them.
Yeah, that's cool. So if you are somebody who's listening, who's thinking about building agents, that you've learned a few arguments from Peter and I as to why you should be doing state management. Just obviously cost, and as you heard from Peter, you can start off by using it with Python or whatever programming language you're familiar with. They kind of support everything. I feel like I'm plugging DBoss here for everyone, but go try it out. It's pretty cool. Peter, let's shift a little bit. Talking about so if somebody wants to get started with DBoss, right? Are you offering this as an open source project right now? Do you have a managed solution? How do they get started with that?
Yeah, so the core dbus libraries are fully open source. You just go to docs.dbus.dev, open the quick start. It'll tell you how to get started with the open source libraries in your favorite language. And the only thing you need to get started with the open source libraries is a database. So a CockroachDB database or a Postgres database. For getting started, you can also use SQLite, but for production, you use a real database. That's our core feed is open source. And then for production use, we also commercially offer a set of tooling. So observability, dashboards, automated recovery. We call that Conductor. So that's our commercial product that provides a tooling that helps you run DBoS workflows in production, and that can be totally self-hosted by you, or that can be managed. That can be managed by us, and that's an intrinsically privacy-preserving architecture. So Conductor stores absolutely no data about your application. So you can Yeah, so you can so, because all of your data remains resident in your database, in your CockroachDB and your Postgres, and Conductor's only there to provide tooling, to provide dashboards, and to help coordinate things like recovery and workflow retention that are useful in production.
Yeah, very cool. So the conductor capability is basically comes with, oversight, monitoring, for everything that they need to run it at enterprise scale.
Yeah, it's tooling. It's like, here are your dashboards. Here's your automated alerting. Here is your managed recovery. Here's your configurable retention policies, the tooling that you want to operate things. But the core workflows library, like the stuff that actually the core stuff that goes in your application, that all is included in the open source library, and all the data from that is stored only in your database. So none of your data is ever sent to us.
Makes sense, yeah. And so, and going back to what you mentioned with databases, you basically bring your own database, BYOD, right? Bring Postgres, bring CockroachDB. With respect to CockroachDB, and what have you like? Tell us a little bit about. Obviously, Postgres. You worked with Michael. Tell me, now, after using Cockroach, of trying that with DBoss, what do you like about the product, and how do you feel it's going to add value to the customers who are going to use Cockroach with DBoss kind of option?
So CockroachDB is an incredibly cool system. And this is something. I read the original papers back in grad school, right? Like, this is something that's been around for a while, that I was researching back in the day, and we're actually working with you guys. The thing CockroachDB brings to the table, more than anything, there's a lot, but the most important thing is scale. Postgres is a single node system. You have your one Postgres, and if you want a bigger Postgres, you get a bigger machine. And if you want to scale past 96 cores, then you get two separate Postgreses and figure out how to shard your data across those. You can do that. It works well, but what's better than that, especially at massive scale, is like an actual distributed system, like a system where you can have any number of nodes and they all work together and give you the abstraction of a single database that's distributed across many nodes, potentially distributed across many regions internationally. That when you're really, really, really trying to run applications at massive, at global scale, then this is invaluable. So I think the two things that CockroachDB, where CockroachDB is, that CockroachDB can do that no other Postgres can do in a DBoS context is first run applications at truly massive scale. If you're processing, tens or hundreds of thousands of workflows per second, and you need something like Cockroach to keep up with that level of transaction volume. And also, like, if you're dealing with data sovereignty issues, CockroachDB is that something CockroachDB, I believe, is also, you know, recently started to like added a lot of support for, where you can specify that some of these workflows run in Europe or in Germany, and they keep all the data resident in Europe or in Germany, and the workloads that data also, the data lives in Germany, and the workloads that touch that data only live in Germany, and that way your global database can remain compliant with data sovereignty regulation in each individual country in which you operate. So scale in terms of transaction volume and scale in terms of like global distribution and the ability to comply with like increasingly complex regulation are places where Cocktree really excels.
No, that's awesome. Yeah, and for everyone listening, and we're working with DBOS, as partners. We're going to have more stuff come out for you if you're trying to use Cockroach with DBOS, and it'll help you get started as well. Um, in this same context, Peter, I want to ask you, like, we were talking about domains and use cases. What domains do you think? I mean, obviously, this is workflow execution and durability is kind of applies in pretty much every tech use case. But where have you seen the sweet spot in terms of domains that can take benefit of DBOS immediately?
Yeah, so we definitely see the fastest growth in agents. And I think that's mostly because the largest number of developers right now are building agents. So anything that's even remotely adjacent to agents is going to see a huge amount of growth. And DBoS is really, I think this is core workflow extraction, specifically DBoS is like a really lightweight implementation of it is, I think, perfect for building really reliable production ready agents. And we also see DBoS used for just a lot of just more core business use cases. Actually, one interesting thing we're seeing is using DBoS for like biotech lab automation use cases where infrastructure has to run on-prem. And what's nice about DBoS is that because it just needs your database, you can run it fully on-prem, maybe even in an air gap lab environment. So you can add workflow reliability to this on-prem system that can't really support a cloud-hosted orchestrator or a complex cluster. And as you're probably not running Kubernetes on your lab, you can run Postgres.
Got it. That's pretty cool, actually. And I'm sure there are so many more use cases out there that people have not tried, but it's going to continue to grow. So that's exciting.
Yeah, like all sorts of business use cases, just data synchronization, big one. Like just keeping two databases in sync is really hard, and workflows are great for that. Something like a login or registration flow is something that often some of our customers start with. This it's often the first thing the customers builds on DBoS because it's fundamentally a workflow, and it's really important that it gets everything right. That when you're onboarding a new customer, onboarding a new employee, you actually register them in each of your systems, and that's the thing. It needs to be reliable. That's a core business workflow that we've often seen as the first thing a new customer builds in DBoS. If the customer is a more traditional enterprise.
Yeah, yeah, makes sense. I mean, that's awesome. Yeah. I wanted to ask this question in the beginning, but we started talking about tech and geeking out about it, so I kind of lost trail of it. Um, you've been doing DBoS for a few years now. What makes you personally passionate about solving this problem for the world? Like, tell me a little bit about that. Like,
Academically, intellectually, like I love databases and I love this idea of reliability, this question of how do we build something that's no matter what kind of weird failure happens, it's going to be robust to that. And that's a really engaging problem. It's a really hard problem that most people don't want to solve themselves because the space of potential failures is too high. And it's a really important problem. Like we need software to work. And
yeah,
especially with agents. Like the specialist agents take on more and more higher responsibilities. We need that software to work. And if software
right.
doesn't work, that can be costly. And if the software is important, that can be costly in real in material ways to real people. And so making it so that software actually does what it's supposed to do, and it's easy to build software that's supposed to do that's a really cool thing.
That's cool. I think one of the things I was thinking about is there like a DBoS skill available that an agent can use to like look at my existing code and then
Yes, we actually recently released agent skills for DBoS. So we have also a DBoS MCP server Skillization is a really cool tool if you're not familiar with it. It lets you just, with a single npm command, install a skill
Yeah.
onto your computer so that
The reason why I said Peter is because it'll be so cool for me to go look at my existing projects. So say I have a Nest JS backend or a Next JS backend or whatever. It's just JavaScript, right? Um, I would basically get an agent, I'll download the skill, and I'll say, look at my project and tell me where am I going to have my system break, and add a DBoS level skill and help me understand that, right? So that'll be cool for me to like run some sort of a, I would say, compliance check and then apply that. Do you think that's a good use case to start off with?
absolutely. Like, I think with these, because these skills, they work. Like with them, your favorite coding agent, a Claude or Codex or whatever, can actually make debug work in a non-trivial program. And these skills we regularly update them so they understand all of DBoS's latest features and APIs. There's also an MCP server, which is cool. And that lets your agent engage with your active workflows. So if you like your workflow, if you're running a bunch of tough stuff in dev, and some workflows fail, the MCP server lets your agent query those workflow traces and maybe dig through them to figure out what went wrong and then fix the underlying issue in your source code.
That's cool. Yeah. I mean, I'm just excited to go try it out. Thanks for telling me. It's exciting. Uh, I wanted to ask you a question related to are you also a gamer? Because I see that headset and I feel like you're a gamer. I don't know if it's true, but looks like a
Yes.
gamer's headset.
Yeah. Yeah. Yeah.
What do you play?
I play. I don't know if this counts as gamer, but I play a lot of Magic. Magic the Gathering. I don't think
Okay.
counts as a gamer, but I like it.
Yeah, that's cool. That's cool. Yeah. So tell us what's exciting. What's coming? What should we be looking at with DBoS? Like, what are you guys doing this year that's exciting?
Yeah,
Something for us to look up to. Yeah.
lots of big priorities. So one thing I think I mentioned this earlier that we recently released is interoperability, the ability to take an application written in DBoS in any language and have an interface with a DBoS written in any other language, like to, for example, in Q work to Python from a TypeScript backend. That's one of the big exciting features that we just released. Some other things coming soon. One thing we're adding is the ability to enqueue work directly from Postgres. So if you're do or for CockroachDB. So if you have, say, triggers on your Cockroach database, you can now take those and use those to uh, start workflows or to send messages to workflows. So
Got
that
it.
like further integrates DBoS into the Cockroach or Postgres ecosystem. So you can do you can do work directly from directly from your database and have it interact
Got
with
it.
your DBoS system.
Very
We're
cool.
also like really focused on observability. One set of things that's going to come out is just a bunch of new tooling to make it easier for you to like view and manage your workflows in production. Like so you can quickly triage workflow failures and then you can open up your dashboard and if there's an issue, immediately see the workload failures and dive in, see exactly where they came from, and do more sophisticated like triage and root cause analysis directly from the dashboard. So observability is another big focus for us going forward. Because one of the big benefits of workflows is that because they're checkpointing all your program's progress, you can observe those checkpoints to see exactly what your program's doing and see why it fails. So it gives you a ton of observability for free, and we want to make our visualizations that much better.
That's cool. Yeah, man, that's exciting. I mean, it's very exciting. What is your own go-to programming AI assistant at this point? Are
Claude,
you a Copilot guy, a
Claude
Claude
Code,
guy,
Claude
or are
Code,
you Codex?
Claude Code, Claude Code.
Claude Code? There you go. Okay, I'm going to ask you an opinionated question. Why Claude Code and not Cursor with Opus?
I tried Cursor back in the day, and I think I bounced off of autocomplete. I really don't like Cursor's autocomplete. My understanding, I haven't tried Cursor in a while, in a couple months. My understanding is that Cursor's moved away from autocomplete and more towards a fully agentic system. Maybe if I tried that, I would like it more. I really hate the NID autocomplete. One thing I really like about Claude is that you can, because I use it a lot, you can separate what your agent's doing from what's in your IDE. So I can have what I usually have is on one monitor, I have Claude actively working away, and then the other monitor I have the IDE where I'm watching Claude. And having those two be separate makes it much easier to understand what the agent's doing. If the agent's doing something funny, I can correct it.
That makes sense. That makes sense. Yeah.
Also,
I like
Claude
that.
Code is heavily subsidized, so get it in, get
Yeah.
it while it's cheap.
That's a good point. Yeah. I'm also a big Claude coder. I don't use Claude Code though. I mean, I use Opus. That's my go-to model. 4.6. With the way these models are improving, And Opus 4.6 is, I'm sure you saw a massive jump in the quality in the last 2, 3 months.
4.5.
Do you
4.5 is a
think
big jump.
4.5 was a big jump? Yes, 4.5 is big. Do you anticipate we would probably just not have to even look at a code at some point and just trust what the agent is producing? Do you
We'll
think that's
see.
going to be the case?
It's not close. 4.5 is a big jump for sure. I think
Yeah.
before 4.5, like I had to be so before 4.5, you had to like be really, really, really picky and tell the agent to do things in like small 5 or 6 line chunks at a time.
Right.
Now I can tell the agent to do larger refactors and let it work autonomously for the order of minutes. But when I come back, there's always something broken. Now, part of it's
So
because like
yeah.
what we're working on is complex, highly concurrent, complex for intricate reliability code, where like a small mistake can completely break a program. Like just to give you an example, like yesterday I was telling Claude to refactor our messaging system, and Claude got it mostly right, but then it just kind of forgot to release a lock because it just probably didn't, it doesn't fully understand what these things are doing, and of course that means everything's double and now everything's stuck forever. So that code would be very, very, very broken. But that's like for basic stuff, for greenfield stuff, it works well. But for anything intricate or complex, you have to really know what your code is doing, or you're going to be stuck forever debugging what turned out to be an AI forgetting it's supposed to release locks.
Yeah. Yeah. No, I agree with you. I've also experienced something similar. What I've seen is my like human in the loop effort has reduced
Yeah,
probably about 20-30% compared for
absolutely.
4.4. Well, I'd say 4.5, 4.6. That's what I saw. I also feel like one of the issues I'm having with Cursor, and I'm reason probably going to try out Cloud Code more, is once you start doing complex, big agentic stuff, as we were talking about, at some point, Cursor starts to slow down heavily. Like the whole laptops, I have like 32 gigs of RAM, but my system starts to like jam as if it's breaking.
Yeah,
So I don't think it's doing
the
great with memory
separation is really
optimization.
nice. Like
Yeah, yeah,
having it, having the agent in your terminal, and then the ID is just an ID with nothing fancy in it. That makes it much easier to figure out what's happening, and it also
right.
avoids like performance issues.
Definitely. I mean, that's awesome. That's great to know. So, Peter, once again, I mean, thank you so much for coming. For all the listeners, do you have anything that you want to leave them with? A place where they should go get started? I know you already mentioned a few things before, but something that you want to plug.
Yeah, absolutely. So I think just try it out. Take a look at our docs, docs.dbos.dev/quick start. That'll get you started in just a couple of minutes on any language. Just install the library, connect it to your database, and go. Also, definitely check us out on GitHub, github.com/dbosinc. That's where all of our open source code is. Come take a look at it, start the repositories. Everything's open source. Everything there is really cool.
Very cool. So yeah, go check out all these things. We are going to link them on the description for on our LinkedIn, as well as when the episode comes out, you can see it in the description as well. Peter, it's been an absolute pleasure having you here. Always glad meeting more gamers who are building cool companies. And I'm glad we matched our t-shirts today. It kind of worked out. But it's been an absolute pleasure. And also from our partnership point, I'm excited about what we're going to do together from our go-to-market. So
Yeah.
it's going to be exciting. Thank you so much for your time. I appreciate it.
Yeah. Thanks a lot, David. Excited to work together. This is really cool.
Awesome. All right. Catch you later. Thank you, everyone.